So hey hello everyone, welcome back to my channel. My name is Sainath, and in this today's video we are starting our new series called Amazon EKS series. So now you may be thinking what this series is all about. So this series is completely open for beginners and also those who are worked with Amazon EKS. So we'll starting from complete foundation level, from understanding what is EKS, why to use EKS, and then we will look into how to use EKS, uh, how to allow others apart from the administrator, how to access EKS cluster, how to create an EKS cluster via Terraform, also via the console way, and then we will be looking into the security best practices like using RBAC, IRSA, and pod identity. How we will look into how authentication and authorization will happen. We will look into auto scaling using HPA, VPA, Carpenter, CA, which is a cluster autoscaler, and then we will look into load balancers, how to set up internal and external load balancers, and then setting monitoring in EKS cluster. So that's the plan of attack, that what I have planned to cover all the topics. But as we will go deep into this series, I will try to add more topics inside this description. And each video will be having a complete GitHub repository created, and link will be in the description. So do check that out. And if you guys are new to my channel, make sure to like and subscribe because it highly motivates me to make more such content. So what are we learning today? So today is the foundation level. So we will try to cover the basic things, understanding what is EKS, why to use EKS, and why most of the organizations prefer using managed Kubernetes cluster over the self-managed Kubernetes cluster. And then we will look into the demo part. We will try to create users, roles, and groups, and allow access to the Kubernetes cluster following the principle of least privileges. And then we will be creating a EKS entries as well for users and roles, and we will look into how users are authenticated inside our cluster, and then are they authorized to perform some specific tasks. Also, we will be looking into that as well, and then we will look into some basic commands that will be helping us to interact with our cluster. And yeah, that's the basic agenda of today's video. And yeah, let's get started now. But before getting started, I want you all to brush up with this EKS clusters architecture. So this architecture is similar with to the architecture that we have with our Kubernetes cluster. So the only extra thing we have is yes, cloud manager, cloud controller manager, and rest all things are same as that we have in our Kubernetes cluster. So I'll be explaining all these components one by one. So the first we have is API server. So API server is like a main communication gateway. So every request coming inside your cluster or request anything going outside from your cluster happens via this API server only. If user is trying to access anything from your Kubernetes cluster, that request will be coming to your API server only, and it will check whether user is authenticated and authorized to perform that specific task or not. If it is, then the further things will happen. If not, you will straightforward get an error. So API server is a main communication gateway over here. And then next we have our scheduler. Scheduler is like a will help us to schedule pods inside our worker node. Means if user is trying to create some pods inside of a cluster, so scheduler is the one who will decide which pod will be deployed in which of the node, and how it will make sure that one pod will be deployed in this node only based on the resources or any specific configuration you have given. Like this scheduler will decide this pod will go inside this node, then it will go into this node based on that configurations or resources like CPU usage, RAM usage, and all those things. And next we have etcd. So this etcd is like a NoSQL database which stores every information about your EKS cluster, like which all pods are running, how many pods are running, which all services you have, ingress, secrets, everything. So every short information about your EKS cluster will be stored in this etcd. It's like a NoSQL database. And then next we have our controller manager. So controller manager is like a it's like a reconciliation loop. Means let me give an example. If user is trying to create four pods, but only two pods are created, so this controller manager will look into that. If user's current state and user's desired state are both matching or not. If not, it will try to create that. Like user has told to create 4 pods, but only 2 pods are created. So this will look into that, and it will create 2 more pods. It will try to match the declared state and current state of your Kubernetes cluster. That's the work of this Kubernetes controller manager. And then next we have this cloud controller manager. So work of this is like um, whenever our cluster wants to access other AWS services like EBS volumes, VPC for networking, that request goes via this controller manager, cloud controller manager. That API request happens via this cloud controller manager only. So that's the work of this. And then next we have worker nodes. And remember, uh, our cluster can have multiple control plane and worker nodes. So we can have multiple control plane and multiple worker nodes as well. And so in worker nodes, we will be having a kubelet, which is an agent. Each worker node will have this kubelet. So the work of this kubelet is like, so this will be directly communicating with our control plane API server. So any request goes to directly to the kubelet only, to any to run any pod. Then kubelet will make sure that pod will be running in this pod only, in this worker node. And then next we have kube proxy. Kube proxy will help us to route the traffic inside our node. Like we will be having multiple pods inside our node. So kube proxy will help us to route the traffic inside our worker node. And then we will be having a runtime, which is a Docker D, container D. Means we everything inside the node is containers only, right? So will be having a container runtime. So this all the three things will be having in all the worker nodes. And this is the user kubectl. User will access our cluster via the kubectl. So this is the tool that will help us to access our cluster as well, cluster only. And yeah, that's all the components we have in our cluster. And when I say that, like this is managed Kubernetes cluster, means it is managed by our Amazon AWS. And when I say self-managed Kubernetes cluster, means the when we managed by the users only, like KubeADM, Minikube cluster. Those are self-managed Kubernetes cluster, and this is managed Kubernetes cluster, which is managed by our AWS. So now let me tell you what is EKS and why to use EKS. So EKS is an Amazon Elastic Kubernetes service, a managed Kubernetes service provided by Amazon. Here managed means the entire control plane, and inside control plane all the components that you have like is etcd API server scheduler or are all managed by your Amazon itself. So you need not to focus on your control plane. They say you just simply focus on your worker nodes and inside deployments, and rest of the things will be completely managed by Amazon itself. And apart from this, you also get native AWS security integrations. Means you can easily use AWS IAM, IRSA, and AWS Pod Identity, and your control plane always remain highly available and reliable because it's completely managed by your AWS itself. And if anything goes wrong to your control plane, it will be patched or updated by your AWS. And you can easily integrate with other AWS services like Elastic Load Balancers and VPCs and EBS volumes. And if you want to migrate the workload of your existing Kubernetes service to any other Kubernetes service, you can easily do that. And yeah, these are the some perks of using Amazon EKS clusters. And also, not just this, Amazon also has something called auto mode. By auto mode, what they say is not just control plane, we will also manage your worker nodes. And they say that you just only focus on your internal things like your pods, deployment, services, ingress. You just focus on your internal workload, and worker node and control plane, we will manage that. That is what Amazon also says. That is called Amazon EKS auto mode. We will look into that in our future videos. And yeah, these are the some benefits of using Amazon EKS. Yeah, I mean, because these are very good benefits. Because like if you work on manage self-managed Kubernetes clusters, there you will be managing everything like control plane and worker nodes. So it's like very hectic to manage everything, because in control plane we have many components like etcd scheduler, and then API server, controller manager. So to manage them and to update them regularly, it's like very hectic work, right? So to use such managed Kubernetes clusters, it's very easy and less time consuming and fast to get into your work and deployments. So now let's get into the hands-on part. And here I want to clarify one thing is that in this video we are looking into the manual creation of our EKS cluster, that is via console way, because I will be explaining how to create IAM users, groups, role, policy, and I'll be also explaining which role is used when and what is the main uh, functionality of using this role or function policies, because that's the foundation level and I want you to know this, because this is the most important thing. And if you get once understanding of this how to do it manually, then automation is just one click away. You can easily do automation via Terraform, any other, or you can do it via Boto 3 also. And if you guys don't understand it or feel stuck somewhere, I highly recommend you to watch this video again once again, or try to take help from ChatGPT also. And another one disclaimer is that this demo may incur the cost from your account, because Elastic Kubernetes service is not covered by your free tier. So use this wisely, because this may incur your cost and can cause some unwanted cost for you. So yeah, that was some disclaimer for you. And now let's get started. So firstly, move to your Elastic Kubernetes service, and also try to stay in any one of the region, because I am in like EP South one. You can choose any one region of your choice and stay in that say, one region only throughout the project. So now simply create a cluster, and in this cluster now, and this is what I was talking about with EKS Automod. This is EKS Automod, means your control plane and your worker nodes both will be managed by your Amazon itself. And here custom configurations, in this you will be creating your own cluster, means control plane will be only managed by your Amazon, and worker nodes will be managed by you. Here, turn this off EKS mode. And next, give name to your cluster. So let me give, yes, give any name as your choice, and I've given this name. And then you need to choose a cluster IAM role. So what this cluster IAM role means? Now your control plane will be managed by your Amazon itself, and now your control plane needs some permission so that it can access other AWS services like VPC, and then Elastic Load Balancer, EBS volumes, and all those things. So we need to give that permission to our cluster so that it can access all those services behalf of you. So for that, you can create that cluster. You can click this button to create a recommended role for you, but we will create our own role, means the same rule, but we will create it manually. So like I have this already created this role, but let me show you one second how to create that. So for that, you will go to your IAM. So once you are here inside your IAM, go to your role and then create a role, choose AWS service, search for EKS, and in EKS choose cluster, EKS cluster, and then simply hit next. See, this is the policy that will be added to your role. And in this policy, let me show you. This policy has all the required permissions so that your control plane can access the other services like attach volume, create route. There are many. So you can simply create this role and hit next. Give any name to your policy. So give any name for you there, and then create a role. So role is created. Come back to your EKS console, and here just hit this refresh, and here it will be popping up. See here. Just choose that. And next you need to choose your Kubernetes version setting. So you will see a bunch of versions over here. uh, Choose the latest version, that is 1.34. If you are seeing it any other version that which is the latest, you choose that version also. And then next, keep everything default, and here down cluster access. What this cluster access means, the one user who has logged in, like I have logged in inside this AWS account. So do you want to give administrative access to that user or not? If you want to give access, allow, or then else you can disallow that. So I want to give administrative access for the one who is creating this cluster, because that is only my admin user. And next is cluster authentication mode. So you need to choose this EKS API way, because previous ones we had something called config map. This is that, and that is not now recommended way to use, because EKS API is very easy to use and recommended way also. So try to use EKS API only. And next, keep everything default and click next. And here you need to choose the networking. And in this demo, we are also using the default VPC only. We are not creating our own VPC and trying to set up all the things over there. And if you have your VPC, or if you know how to create a VPC, then you can choose there and go forward for that. If you want to use any other VPC, then click here and you will see other VPCs. But now we are going with default, and we'll keep it default and then choose the subnets. So if you are choosing the default one, don't make any changes, keep everything default only. And if you are choosing your own VPC, try to choose the subnets only, private subnets, not public subnets, because you want to make your EKS cluster private, right? So for that reason, you need to choose only private subnets. But if you are going with your default VPC, keep it everything default only. And next, additional security group. This is optional, you can give or not. We need to give in the security group over here, but I will give you it later. And next, choose IPv4, and then keep everything default, and then cluster endpoint access. So this cluster endpoint access is like that API server I had told here. This API server. You want to make the endpoint of this API server public or private. That is what it is asking. So let us make it private, because I want to make it access only for the some specific users. That's the reason, and it's also a recommended approach also to make it private. And then click next, and then next is to observability part. So these are all the advanced concept. We will try to cover this in our future videos. So don't make any changes over here. Simply click next, and next choose any add-ons. So don't make any changes here also. Just simply click next, and again click next, and you can review all the things that you have made changes, and then simply create. So it will take nearly 5 to 8 minutes to provision your cluster, and by this only your control plane is getting created. After this comes in active state, you will be creating your node groups. So I will pause this video now, and I'll commit after, once this cluster is in active state. So now once your cluster is in active state, you can, in this overview tab, you can see all the informations about this. You can see your API server endpoint, that is this API server's endpoint, and that is private one, so that only specific users can access that. And then you have a certificate authority, because all the communication happens a secured way, HTTPS. So for that HTTPS, you need a certificate, and this is that certificate. And then you have this OpenID Connect. By this, you can get short-term credentials to access other AWS services. And then this is the IAM role of your cluster. And next, you can come to this access tab, and inside this you can see here two things. One is a role and another is user. How I concluded that this is a role, here you can see this is a role and this is the name of that role, and this is a user and name of the user. This one is created by default by your EKS, and this is the one who created this EKS cluster, that we gave him the one who creates this cluster as administrative access. So this is the role that is got, Amazon EKS cluster admin policy. So this is the administrator of this cluster, admin user. And then next, come to compute, and from here you can create your node groups. So add a node group. So now let's create a node group. Give any name to your node group. Let me give any name, demo ng, and then here you need to give the node IAM role. The same way you give a role to your cluster control plane, here your worker nodes will also try to access other AWS services. So for that, you also need to create a role. You can create here and can get a recommended role from here, but we will create our own role. Here I have, but let's create a one new role. Come to your IAM once again, and come to your roles, create a role. And all in documentation I'll also explain how to create those roles and all, you can check that. Come to role, and then AWS service, choose here firstly EC2, and and then and then click next, and over here you can search for this policy. Just copy that and paste it over here, and then just tick this box. And next is tick this EKS CNI policy, and then worker node policy. So you will be needing these three policies for your worker nodes, and then simply hit next. So these are the three policies that have been added, which are AWS managed, and then create role. I think we need to give any node name. Managed worker, and create a role. So this will create a role, and then come back to your EKS console and hit this refresh button, and here you can see that role. This is the role. Just click that, and next keep everything default. Hit next, and here you need to choose the AMI or which worker node or AMI type. So keep it default, or if you want any other specific, you can choose it from here. And then capacity type on demand, instance type. Let's take T3 medium. Let's take T2 medium. T2 medium, and don't take two different instance type. Take any one instance type, because your EKS will get confused of which instance type to create. So always try to choose only instance type of only one type. Means either choose T3 medium or T2 medium. Don't choose two different one. So we'll choose T2 medium. Disk size, let's keep it default, and desired size, minimum size, and maximum size. Let's keep it one. Let me explain you what are these. So maximum size is, let's keep maximum size as 1, minimum size is 1, and maximum as 10. What do I mean by this is, your worker nodes, if your worker nodes gets too much of traffic, your worker nodes may scale up to 10 nodes, and if there is no traffic, it may scale down up to 1. That's the meaning of this minimum and maximum. And desired state is how many nodes do you want right now currently. You can take 1, 2, 3, anything. So but now for demo, let's keep it everything 1 only, and keep everything default. Click next, and next you need to choose subnets for your worker nodes. Again, if you are using your own VPC, then try to choose the private subnets. But as we use the default VPC, we will keep everything default only. Click next, and then everything is right. Just simply create. So again, this will take again 4 to 5 minutes to create your worker node. So have patience for that. And once this will be in active state, I'll be coming back. So till then, I'll pause this video. So now come to your compute section, and here you will see your node group is in active state. So now your control plane and worker nodes, which is a node group, are both in active state. So now let's access this cluster. But now from where we will access this cluster? So one thing is we can access it from our own terminal. But for there, you should have your kubectl installed. So what is kubectl? I have told that this is a tool through which you will be accessing your cluster. So you need to install this tool inside your terminal. So you should have that tool installed, and also you have AWS CLI installed with the user configured with that. And like I would have chosen my own terminal for the view to show that, but all those things are pre-installed in my terminal. So what I will do is I will run a EC2 instance, and that EC2 instance is my local, and inside that I will install everything from scratch, and I will show you how to do that. So, and I also recommend you to do that in that way only, because you will learn how to install other things and to connect with your cluster. So for that, go to your EC2 instance and provision a EC2 instance. And I assume that you know how to provision a EC2 instance. Give any name, choose of type Ubuntu, choose let it be T3 micro only, choose key pair. If any key pair, if you don't have, you can create it key pair. And I assume that you know how to do these all things. And keep everything default. And then let's take the storage as 20 GB and simply launch instance. So this is our Bastion host, and this is the one our node group. This is managed by our EKS. So click here, connect SSH client. Just copy this. So yes, now we are inside our Bastion host, which is acting like our local. So now before starting everything up, let me first update this. Sudo apt update. And then we will install our AWS CLI first. So the commands are provided in this GitHub repository. You can take those commands from there. Just take this and then paste it over here. So this will install your AWS CLI. And next is to install kubectl. Take this, paste, hit enter. So now both AWS CLI and kubectl are installed. And now we installed our AWS CLI. And now we need to configure this um, terminal using this AWS configure command. So what this command does is it will connect your terminal with your AWS account. So it will ask for your two secret keys, that is secret access key and secret access key. So now you need to have this both keys. How to create now them? Come back to your again IAM inside here. Go to your users and the one user you logged in inside this account. Go to that user and under this security and credentials down here you'll be seeing access key, create access key. But I have these keys already created. I will use those keys. You can easily create that. Just simply create access key, choose command line, and then check this box, and then simply hit next. You will get both the access key and secret access key. Keep them handy because you will use those keys regularly, or you can simply install that CSV file for that. So what I will do is I have already those keys. I will use those keys now. And I also recommend you to use your own credentials. Don't try to use my credentials, though I will try to hide them. uh, Try to create your own credentials and use your own credentials. Keep everything default and simply hit enter. And now your terminal is connected with your AWS the user. Now how to check that? For that, this is the command AWS sts get caller identity. So you will get these credentials, user ID, account, and the ARN of that user. This is the user that has logged in inside this cluster. Now, this user has administrative access. Now, how to check that? Come to your IAM inside users. In this permission, you can see that this user has administrative access, which means he can access any AWS services. You can verify that. Use this command and see. He can see which all clusters running inside your account, and also he can even describe that cluster and see, because he has that permissions to do. He is administrative access, so he can easily access that services. See, he can AWS EKS describe cluster hyphen hyphen name of your cluster EKS demo. So you can easily describe our cluster and can see the informations. But can he access our cluster? Let's see. kubectl get pods. So we got an error. Now why we got this error? Though he is an administrative user and he can see our AWS services inside our terminal, but why cannot able to access our cluster? Because we are accessing our cluster via kubectl, and our kubectl says, which asks you which cluster you are trying to access, and kubectl simply says that I don't know which cluster you are trying to access. So for that, you need to first have a you need to use this command. By this command, a .kubeconfig file will be created in your local, and in that kubeconfig file, all the information about your cluster, like your EPA server, and then security manager, and YDC connections ID, all those, and the one user has logged in inside your cluster. All those information will be present. So let me show you that. So use this command. Change the region. One the region which you are in. EP South 1. This is the region that I am using, and name of your cluster demo. So once you will hit enter, see, added a new context, and a .kubeconfig file is created. So in this location .kubeconfig. So let's go inside that and see cat.kubeconfig. See, here you can see all those information about your cluster. And now kubectl get pods. Now, though we have made those changes, we have made a .kubeconfig file inside our local available, but still our request is not getting processed. This is because we are sending request from here. That is because once our request is coming from this kubectl inside our control plane, and but our control plane, that node is not accepting any requests, because our request is coming as an HTTPS request. So we need to open a port, security group port on this control plane. So for that, come to your EKS, and inside networking, in this cluster security group, you need to add one inbound rule of 443, which is HTTPS rule. So here click edit inbound rules, add a rule 443 for HTTPS, and then you need to allow for this. We are accessing it via our this instance, this, which is our local. This is our EC2 instance. Our request is going from here to our control plane. So we need to allow the security group of our this instance to our control plane. So for that, we will take a security group of this. Come to security. In this security, you will see this security group. Just copy this. Come back to your EKS here, and just paste that. Here you will get that security group. Just click this and save rule. Now the security group has been updated for C. HTTPS 443 rule is now opened. And now you come back here, and again just once again hit this. See, you got the response, because no resources found means because we do have no pods installed over here, but you can access any other things. Let's say kubectl get ns. This ns stands for namespace. Kubectl get nodes, See, we are only just single node. He is able to get that. Now, he is administrative access. Means uh, in this EKS, in this access, this is the one user that who is trying to access our cluster, and he has admin policy, cluster admin policy, which means he can easily create, delete, or add anything inside our cluster. So let's check that. kubectl. Let's create a namespace. Create ms demo. See, he is able to create that. Why? Because he is admin and he has access inside our cluster. And yeah, that's how you add a user inside our cluster. And this is the admin user. Now let's add some other user and see whether he will get an access or not. So now uh, let's try to create one more user and see whether he will able to access our cluster or not. So for that, come to your IAM inside users. Let's create one user. Let's give his name as what name you let's give him as intern. And do you want to give him a console access? No. Just click next. And here you can attach some policies for him directly. But for now, we will not add him any policies, and we will see how that user will be creating access. Just click next and create user. Now we have this intern user. Just go inside that. Now inside this security credentials, scroll down, create access key. Let's create a access keys for him. For command line, I understand this. Next, description, this is optional. Just create keys. So you will get access key and secret access key. So don't try to use my access keys, though I will delete them after this video, and use this access keys, and keep these access keys handy because you will get use this access keys frequently. Just take this and come back to your terminal. Now that user you created, this intern, he will try to access this cluster from his local. Now again, I would have create one more EC2 instance and set up all those things and try to made access give access to that user from that terminal. But now what I will do is create the same one more user in this account only, and I will show you how multiple users can access the cluster from same account only. For that, we need to create a profiles. So I will show you how to create that also. So for that, you need to use this command AWS configure hyphen hyphen profile and give any name to that profile. Let's give a name as intern only and click next. So it will ask for access key and secret access key. Just paste those keys. Keep everything default and hit enter. So now let's check that. AWS STS get caller identity hyphen hyphen profile as intern. If you use this hyphen hyphen profile intern, then you will get so command is wrong. So caller identity. See, if you use this hyphen hyphen profile intern, you will get his credentials, means his profile. But if you use without this profile, you will get this user wings profile because this is the one that we accessed previously. If you use hyphen hyphen profile, then it will be accessing intern. If you use without, it will access this user wings. So now let's see whether he will be accessing our cluster or not. Previously, we saw that when he was using this command, he was able to access. But now when we use this command, he is still able to access because this request went via that wings user, which had admin access. But use this same command using hyphen hyphen profile. See, he simply got an error. Why? Access denied exception. Because we created that user. So let me keep these two things handy firstly. Because we created that intern user and we never added any permission to that user. So he is getting that error. See, here that is the error he is getting. He is able to list that clusters, so he is getting that error. But the same if we run without that hyphen hyphen profile, this user is able to access because this is going as a that admin user wings, and this is going via intern user. Request is going by intern, so he is getting error. So you saw this thing. Now one thing you get clear is that you need to add permission to this intern user so that he can access our cluster. So you need to add those permissions now. So now let's add some permission to this user and see whether he will be able to access our cluster or not. So for that, come to this permission sections, add permission and attach policies directly. So here I have one self-managed policy, that is this, and in this policy I have given this describe cluster and list cluster permissions. So I will use this policy. Let me show you how to create this policy also. So simply click next and add permission. So to create that policy, you go to policies, create a policy, uh, come to JSON. Simply you choose the policy, that copied policy. I will attach that policy in the GitHub repository. You can directly choose that policy from there, or you can choose it from here also. Like a resource action. For action, we need to check for describe yes in EKS. In EKS describe cluster, and another is list cluster. This. So keep these two policies, and resource keep as uh, everything, all resource. Keep all resource, and then simply create next. Next. So it will ask some for some policy name. Give any name to that policy, and then create policy. Your policy will be created. Though I have because I have already created that, I will not create that once again. So next is now policy is created. Now let's test that. Uh, so this was that EKS list cluster via this intern. See, now he is able to access that because now we gave him that permission. Let's see whether he is able to describe that cluster or not. Yes, he is also able to describe because we gave that permission to him. Now let's see whether uh, now that we added that user and gave him permission to access our cluster, but is that user present in our cluster or not? How to check that? Come to your EKS cluster in access. We'll see that we don't have that user here. So that user is not authenticated. So we need to authenticate that user. Now how to authenticate that user? We need to create that user over here. How to create that? Click create. Choose the ARN of that user. So scroll down. See, this is the intern user. Just click him. Keep everything default. And then click next. So what policy you want to give him to that user? So you can choose that from here. Let's give him minute policy, like let's give him view policy. View policy, what scope you want to give, to cluster or to any specific namespace. So to this cluster namespace and all, we will learn this in our RBAC section. So but now let's keep it simple. We will choose this cluster and click this add policy. Next. Now a policy is added. Create next. So now our intern user is added so that he can access our cluster. See, we have that intern user and he has Amazon EKS view policy. So now let's check whether he is able to access our cluster or not. kubectl get pods. But again, this request went via that admin user that we had logged in previously. If you want to that request to go via your internal role, you need to again update this your local using this command. Again, this is very much confusing, so I highly recommend you to stay connected with me. And if you get confused in middle way, rewatch this video, because this is the way you will understand also, because this was also very confusing for me also when I started learning about this. So use this command, enter, and over here region as AP South 1, and then EKS Demo hyphen profile. So use this command and then simply hit enter. So again, our kube config is updated. You can check that cat.kubeconfig, and here you will see env as a profile. If you see that env means your kube config is now accessing via this intern user. So now let's check whether he is able to access or not. kubectl get pods. He is able to access that, though we don't have any pods over here. But see whether he is able to access other things. kubectl get nodes. See, now he got that error, because with this policy that we gave to this user, intern user, Amazon EKS view policy has some specific permissions to perform. In that permission, he don't have access to this access nodes. Let's see whether he is able to get NS namespace. Yes, he is able to. But kubectl create NS. Let's see whether he is able to create a namespace or not. Let's say let's give namespace as interns only. Again, he got error, forbidden error, because he don't have that permissions to perform. He has only permissions to access our cluster, and that is how you do authentication and authorization. So here, authentication part has happened. That the user, we added this user, and that user has been authenticated with our cluster. And now inside this, he is trying to create a cluster. This is authorization part. He is not authorized to perform this task, but he is authorized to view the cluster, like kubectl get pods. He is authorized. He has that permission to view pods. He has permissions to get namespace also. So this is authorization part. So this is how you perform authentication and authorization for users inside of a cluster. And yes, that's how you do. And now we will see how to do this with the groups, because if you have multiple many users, like 10 50 users inside your cluster, to manage that users and give permission to all those users, it's very hectic work, right? So now what we will do is, let me show you from here only. So what we'll do is, we'll create a group. So now you have users, right? Like you have such users. If you have such multiple users, to manage these all users with some specific permissions, it's very hectic work, right? Now what we will do is, we will create a group, and we will add this all users inside this group. But before adding, now we used to give permissions policies to this all users, but now we will give policy permission to this group, and add these all users inside our group, like this. Now whoever present in this group will able to access our cluster. That's the basic rule of this. Now got it? Means we just create a wrapper over our users, so that they can whoever present in our group will able to access our cluster. That's what I'm saying is here. So now come to your IAM console, and here IAM console. So we have created this intern user. So now I also created one test user, and this test user don't have any permissions over here. So now we will add those both intern user and test user in our group. So for that, come to your users group, and here we will create a group. Click. and give any group name here. Let's give a demo group, and in this group, which all users you want to add. We will add this intern and this test user. And then, do you want to give any permissions to that group? Yeah, we want to give the one that we gave to that user previously. This one, Amazon EKS developer policy, and this policy has permissions like to describe cluster and list cluster. So we will give this one policy to our group. Now both this user can easily access this policy. Create user. So see, a demo group is created and it has two members inside it. Who are those? Intern and test user. And permission to this group has is this. Now come back to your EKS console. So now in EKS console, you have let me refresh this. So now your EKS cluster, you have your intern user and this wings user. Now let's add that this test user also. We need to have that test user also in our EKS. But now I will not show you to how to create it from this console way. I will show you how to create it via terminal. So from here we will creating that user. So for that we have commands. Come in your GitHub repository. You can find all those things here. So to create access entry, just take this command, paste it over here, and just change this ARN. Take the ARN of your user, this test user ARN. So ARN of the user is this. Take this and then here. Paste that. So the your cluster name is EKS demo and which user you want to add and type as standard and simply hit enter. And access entry has been created now. Now you can easily view which all users are present inside your cluster. Take this command and paste it. See here, you can see all those users and roles created. You have this wings user, test user, intern user, and these two are the roles that we created. So now we added the user, but this user don't has any permission to access the resources of our cluster. Now we need to add that permissions to them. So to that, this is the command AWS EKS associate access policy. So take this. So paste that here, and you need to change something over here. So for that, firstly, your cluster name is EKS demo. That's right, and then principal ARN of your user. So this is the not this. So to this user, we want to add some policy. And which policy is that? ARN, ARN AWS EKS cluster access policy. But we will give him which policy? View policy. And let me share that. Which is that policy? This policy, Amazon EKS view policy. Just take that and over here paste. And simply hit enter now. So yes, now the user is created and policy also added. You can verify that it over here. Just come here and just simply hit refresh. And down here you will see that test user, and for him he has this Amazon EKS view policy. And now the rest things are simple. Now go to your IAM user. So in this IAM user you have that test user. Take is both access key and secret access key. You can create that from in this security credentials. From here you can create that access key and secret access key, and add those key over here. Terminal AWS configure, do that configure, but add a profile over here. AWS profile. Let's give him as a test user, and then simply hit enter. So it will ask for access key and secret access key. Add those keys. A profile for test user will also be created, and now he will also access your cluster. Now we added those both credentials. Now let's check that AWS STS get caller identity one hyphen profile test user. See, you can see these credentials. Now let's try to kubectl. But before that, we need to update our local. So for that, we have this command. This one. Just take this. Here you need to change AP South one EKS Demo profile uh, test user, and then simply hit enter. Now kube config file is updated. You can check that .get kube config. You can see a kube config is updated for AWS profile as test user. Now kubectl get the pods. See kubectl get nodes. He will get error. See forbidden error because you don't have the permissions, because we only give view policy. So yes, now we saw both the way to how to create a user via console way, and then we saw how to make use of the groups so that we need not to give permissions to the specific users, and then we also saw how to create access entries via terminal using command line. And now what we will do is, but also you think that this is not a good practice. The recommended way is to create a role and allow users to assume that role and access your EKS. That's the most recommended and secured way. Now we will look into that, how to create that. So firstly I will explain you from this blackboard, and then I will do the hands-on part over there. So now we will create an IAM role, and to this role we will give the permission to describe and list the cluster. The same way that we gave to this group permission, we will give the same permission to this role also. And we will use to add the users inside this group. Now what we will do is, now we have two users. One is intern user and another is test user. Now we will say we will also create one trust policy, and in that trust policy we will say that only these two users will assume this role, so that no other user can access this role. That's the basic thing. So we will add two things to this role. One is permission and another is trust policy. I'll show you that how to do a demo. So this role has these two things. One is permission and this trust policy. And in this trust policy, we will say that only these two users can access this role. And now we will add this role inside our EKS. The same way we used to add here. We used to add multiple users, right? The same way we will create a role over here. From here, we will create a role. For that, this role, and with that role we will able to access our EKS cluster. Now if you feeling confused how we are doing or what we are doing, stay stick to me. I will explain it again much clear while doing the demo, so then you will get it complete clear. Now come to your IAM console, and in this role section click here create role and choose custom trust policy. And in this custom trust policy you need to add your users to whom you want to give that permission. So add this principal, choose IAM users, and then add your account number and the username. So the user whom you want to allow that role to assume. So one is this user, add principal. See, so this principal is added. Now add one more principal, IAM user, So another is the test user and add principal. See, those are added now. Click next. And now you want to give any permission to your role. Yes, we want to give, and that permission is this self-managed Amazon EKS developer policy. And in this policy we have that again, this describe and list cluster policy principle. Simply click next, give any name to your role, EKS role access, EKS role access to users, and then create a role. So now a role is created, EKS role access to users. So this is the role that, and now come back to your EKS, and inside this in access, create access, and choose the ARN of that role. EKS, what is that? EKS role access to users. Now choose this role, type as standard, click next. Now what permission you want to give to that role? We want to give the same policy, which is a view policy, Amazon EKS view policy. Click this policy, and then keep it cluster, add policy, click next, and create role. So an access entry for role is now created. But now we need to update this, update it over here, so that we can assume that role and access our EKS cluster. So now we created that role. Now let's create an EKS profile for that role. So for that, firstly let me show you this cat.aws config. So these are the profiles that we previously created. The default is for admin, and then intern profile, and then test user profile. So now let's create a profile for the role that we created now. So for that we have this command. Just take this command, paste over here, and put the ARN of that role. So let me first zoom this out and take the ARN of this role. What is that? EKS role user. This is that role. Take ARN of that role, paste that, and then we have role session name. So here give any name to your session. Let's call it user session, and then profile. Give any name to your profile. Let's give it as an EKS user view, and then hit enter. So profile is created. Config profile could not be found. Oh, oh, we are getting this error because we need to manually update that. So for that, what you need to do is you need to go to this, and here you need to add that first profile. So how to add that now? Vim.aws.config, come over here, and here add a profile. Profile, EKS user view, and which profile will assume this role. Now take the source profile, but before that you need to add this role also, role ARN. Role underscore ARN equal to ARN of that role. So ARN of that role is this one, and then source profile. Let's use source profile as intern. So yeah, now we created this profile for our role. Now let's use this command to use that role. So here change your region south, south one, name of your cluster demo, and then profile. Open profile, which is your profile? EKS user demo, user view. This is your profile. Hit enter. So now our kube config is updated. You can check that dot kube config. So as a profile as a user EKS view. Now let's test that. Kubectl get pods. Yeah, kubectl get nodes. We should be getting a forbidden error. And yeah, we got that. Kubectl get ns namespaces. Yeah, and now let's create a namespace and see kubectl create ns admins. Again we got error because view policy don't has that permission. Yeah, now we have created our role also and allowed some specific users only to access that role. Now if you have multiple users in our EKS cluster, and in this role trust relationship that we created, if those users are not present here, then they will not be assuming that role, and eventually they will not be able to access your cluster. Only those two users can assume this role that we created, this role, and then can access your EKS cluster. And that's how the authentication and authorization part happens. But authorization is happening only to the some specific thing. Fine grained authorization will only happen while using RBAC, IRSC, and pod identity. That is what we will look into our next video. We will try to create those RBAC and all, and give some specific permissions to our access the Kubernetes services, like only pods should be viewed or only pods should be created, or we will give permission to specific namespace. Such all permissions can be happened only using RBAC. So we'll look into that in our next video. So yeah, and the demo for this video has completed now. You have looked into how to create the users group, IAM roles, how to authenticate user, how our users are authorized, and how you will get errors like forbidden, everything. And if you guys feel any stuck or don't understand that, I recommend you to watch it again or try to take help from ChatGPT. Ask it why this error is getting, why we need to give this permission role. You will get to it clearly, because this is very confusing step, I know. And but when we will create it via automation, via we'll create it with Terraform, then we will be with only just one click. Everything will be automated and every infrastructure will be created for you. So yeah, that's the end of this video. And now don't forget to delete the resources. Now how to delete this is very important, or else you will end up incurring the unwanted cost for your account. So come to your cluster. Firstly you need to delete your node group. Come to compute section, click this and delete. So by this your node group will be deleted. So again it will take 3 to 4 minutes, and once your node group is deleted, you delete your cluster. How to delete that? Come back here and just click it and click this delete button. So again that cluster will also take some 2 to 3 minutes to delete your cluster. And once your cluster is also deleted, you can go to your EC2 instance that you created. So this is that EC2 instance. Click this and you can stop or terminate whatever you want. So let me terminate this. So now EC2 is instance also terminated. And yes, that's it for this video. If you found this video helpful, make sure to like and subscribe, because it really motivates me to make more such content, and I'll bring more such videos in this series. And yeah, stay tuned for more such video. Till then, bye bye.